So now we could say how a simple recurrent neural network will be from the artificial neural, how this differentiate. So a simple neural network, this is a artificial neural network. We have an input layer, we have some hidden layers, and we have an output layer. The activation functions will be there in the hidden layers, and weights and biases are there inside these lines or inside these connections. So how this recurrent neural network will be, this will be converted into a recurrent neural network is that this A, B, C are some parameters. Okay, A, B, C are the parameters of this, and this H is feed forward, right? H is feed forward. So X is the input parameter, H is the hidden layer, and Y is the output layer. And this H is given back. So this, this simple is not simply we are back giving, it is feed forwarding, it is normally forwarding, but the hidden layer information is also forwarding to the next hidden layer, then only it will be a sequential information. For example, here we can see this could be converted to this. So what's happening here? Here the input layer X takes the input to the recurrent neural network and processes it and passes it on to the middle layer. Okay, so middle layer. The middle layer H can consist of multiple hidden layers, each with some activation functions and weights and biases. So the recurrent neural networks will standardize the different activation functions and weights and biases so that each hidden layer has the same parameters. So this is the another version of recurrent neural. So what is happening here? X of t minus 1, x of t plus 1. These are the input functions, right? You can consider t minus 1 as 0, so x of 0, x of 1, x of 2, and these are giving with a bias to the hidden layers h of t minus 1, h of t plus 1, and y of t minus 1, y of t plus 1 are the output. So this h of t minus 1 is passing on to h of t. So the first input is forwarded first in, this is a variable input, right? So for this, for example, we can consider x of 0, x of 1, x of 2 as the my name is Arun. This is the sentence I wanted to give to the network. So x of t minus 1 will be my, x of t will be my name, and x of t plus 1 will be is, and h of t minus 1 will have some form of what information carried upon the first input, and this information will be forwarded to the next, because for sequential classification, sequential sentences, it is very necessary to have some information of the previous one. Okay, and this y of t minus 1 etc will be again a variable outputs. So with this we have already learned why recurrent neural networks, what is the need of recurrent neural networks, because there are few issues with the normal feed forward artificial neural network. It cannot handle sequential data, that means it can have a fixed size of input and output. It considers only one current, only current input, right? There is no any memory forwarded, that means there is no, cannot memorize the previous inputs. This is the solution for RNN. So that initially we have seen a loop in the H, right? So this loop here for unrolled, that loop how it is unrolled here, it is H of t minus 2 is given to H of t minus 1, t minus 1 to t, t plus 1, t plus 2, like that it is forwarding that memory. Okay, now what are the real life examples of sequence learning applications here? We have stock price prediction, that will be a prediction or a regression problem. You know what is a prediction problem and a regression problem. These things you have already learned in your soft computing. Okay, so I'm not going to talk about what is prediction, what is prediction in the sense classification. Regression is another type of thing. Then row sensor data. Sensor data is a real-time sequence data, right? If we are collecting a temperature sensor and we are collecting the current temperature of this room, then this will automatic real time it is taking, it is acquiring, so it will be changing initially. So it's a sequence of data. Next is text sequences, sentiments or text sentences we will use for machine translation, Google Translate, question answering, chatbot, etc. Next is image and video. Not image, video, text description, caption, scene interpretation. All these are different types of AI problems. Okay, so these are some of the tasks we need. I mean, the table shows that which are the tasks we need to we can solve through RNN. So which are the inputs which are having differential input column, or I mean sequential data, which are the input sequence. What are the outputs of sequential? This is the same thing that unrolling RNN, etc. Now we have to know about what are the problems of this RNN. We have two problems with this. One is vanishing gradient, one is exploding gradient problem. So vanishing gradient matlab what, from the name itself we will came to know that the gradient is vanishing. Vanishing means that the gradient is infinitely small after some point. That is, recurrent neural networks enable you to model time-dependent and sequential data problems, as we know. But at some times, the gradients that we are passing on from one state to another, which will becomes too small, and at the last, it will be very difficult for the parameter to update. See, from each layer to layer, if this gradient is passing on, the parameters are also updating. That's how finally we are reaching into the problem, right? Parameter tuning, all this hyperparameter tuning, etc. we have already learned. So what happens if this gradient, if the algorithm will not train, or algorithm cannot learn, if this gradient becomes too small or the parameter updation is not happening, that means this makes the learning of long data sequences difficult. That means RNN fails to learn long data sequences. We are not talking about one sentence or two sentences or some paragraph. It is talking about many sentences. Okay. The another problem is exploding gradient problem. Here what happens, instead of decaying or increasing gradually, if that slope tends to grow exponentially, or gradient exponentially it grows, then this will have a exploding gradient. That means this problem arises when large error gradients accumulate, resulting in very large updations happening. So when large updation happens, matlab neural network model weights will increases during the training process. So what are the disadvantages due to this? Long training time, poor performance, and bad accuracy are the major issues. So what are the solutions for these two problems? For exploding gradient, identity initialization. We need to initialize some identity before itself, so that it will not grow much. Then truncated backpropagation, that we will learn soon. Then gradient clipping. Next is vanishing gradient problem. How to solve vanishing gradient problem? One is weight initialization. We have to initialize the weight at a proper age. Then choosing the right activation function. It will not make the gradient too small. ReLU function is one function that we can take upon for this purposes. Next is LSTMs, long short-term memory networks. This is another variation of RNN that we can use for mitigating these two gradient problems. This LSTM we will see in the next class. So this is how exploding and vanishing gradient problem is shown in a graph. This is some, I mean, you can go through this. You can immediately get. So as a summary, I could say we have seen to how the RNN have processing the long sequential data, how to memorize the previous input, and then we have to forward this. We have given some applications of this recurrent neural networks. What are the problems of the artificial neural networks? We have seen these are some of the sequential inputs and variable outputs, and these are some of the applications, real life applications of RNN, and which are the disadvantages, how to mitigate that disadvantages. Okay, so I hope everyone is clear about this. So in the next class, in the one-to-one class, I mean in our online lecture, you just go through this Then you will understand any difficulties there or any problem in finding anything. Then we will discuss it in the next class in one-to-one discussion. Okay. Thank you.